Good afternoon to you all. Good afternoon. Good afternoon. Can I see you, please? I want to talk to real people, but not to just to blank pieces of screens. Thank you, Valeria, Alexandra. To Alexandra we have Valeria, Artyom, Valentina, Andrei, Nikita, Ola. Thank you all. To Olas, Denise, Diana, Maxim, Evgenia, I want to see you, please. Turn on the webcams. Good, great. I see that some students have decided to join us earlier. Maxim Fedorenko. It seems to me that last time you attended the second session meeting, right?
Yes.
Today you've made a change. Good, great. Does everyone remember that if this time is inappropriate for you, it's unsuitable, you may join me a bit later at 2:10. Всі пам'ятають, що о 14:10 також є можливість приєднатися. We will do this same, це буде такий самий урок, it will be this same question, or the same lesson, but it's just for you to choose a better time. Got it or not? Nikita, I see Dirabin, Nikita has also made these changes. Good, great. So no one is going to join me today at 2:10 or what? Or you don't know? What would you say?
I say yes.
Say yes is what? Say yes is what, Nikita?
You say that I changed the session and I agree, and that's all.
What about the others? What about the others? Who knows? Perhaps you have discussed it in your groups. Is there anyone to join me today later? Is there anyone, other group mates of yours who will join me later, or no ideas? You don't know, you have not discussed.
We don't know.
You don't know, I see. Does everyone know what we are doing currently? Всі розуміють, чому ми тут зібралися? No one made you, No one made you, just forced you to join. Ніхто ж вас сюди не змушував приходити, правильно? Not your neither your parents, nor me. І ні батьки, ні я. It's optional, it's elective, it's just, it's your own choice, not mine. Does everyone remember that in winter you will be tested in 4 activities: reading, listening, speaking, and writing? Yeah, do you remember? It's gonna be kind of challenge at the very end. Good, great. And do you remember that the certificate will be, we will be given to you in case that the average score will be not less than 76. Do you remember it? Yes, you do. And one more thing, those who skipped the previous class, don't get into that. You have the first that. Did you see the home task? What is the topic for an essay to complete? Did you see it? So don't get into that. Ніхто не набирає боргів. Хто не був відсутній, а прийшов зараз, перша тема має бути закрита. Есей зроблене і мені відправлене в особисте. Got it or not? Якщо будуть мінуси в кінці по якійсь темі, це не допуск. Я не допущу до іспитів. Ходили, не написали, все. Sorry. Got it or not?
Yes.
If yes, let's start. If no more questions, are there any questions left? Or everything is clear, more or less?
Everything is clear.
Okay, good, great. Remind us, please, Denise Piven, remind us, please, the topic we had last time. What were we talking about? What were we discussing, Denise? What? Say it louder, please. Yeah. I see. We talked about AI, we talked about artificial intelligence, and we gave a definition of AI, saying what, Alexander Halavai? How did we determine it, the concept? What is this?
We talk about different technologies, about machine learning, how it works, and where it used in our lives, in our life.
It's not the definition. I asked you to define the concept. Who can? It's what we were talking about application, yeah, about more than directions, about subtypes, but I haven't heard any definition. Evgeny Vasilyev, how would you define it?
Last time I defined it like systems that can get some information, analyze it, and do some task that we want it to.
A bit unclear, Evgeny, yeah? Taking into consideration the thing that we have finished it already, it's a bit unclear. It's not your level, my dear. So for exam, yeah, you need to define AI exactly and correctly, but not, I think that to do what we ask it to do. No, it's like not professional. The types, there are 3 types of AI. They are, Ulyana Kostyuchenko, according to the quiz, yeah, you did last time, you learned that there are 3 types of AI. They are?
I don't remember.
Diana Zloshchasteva remembers? Who remembers? Okay, who remembers the 3 types of AI?
With supervisor, without supervisor, and reinforcement learning.
And reinforcement learning. Yes, Mike, thank you. Supervised, unsupervised, and reinforcement learning. What's the difference between supervised learning and reinforcement learning? As if they look the same. Yes, Valia? But there is a difference between them. What is that?
There's a difference between all of the steps. Can you please repeat which one should I compare?
Supervised and
least?
reinforcement. Unsupervised is clear.
Okay.
No teacher, no monitor.
Yeah.
But I'm interested in supervised and reinforcement. In both cases,
Okay, yeah,
AI is managed by, is monitored by someone, by us, by humans.
Yeah.
What's the difference?
As far as I know, both of the steps have correct answers when they are when they are training. But supervised learning has a goal to minimize a mistake, an error, and the second type has the task to maximize the reward it gets for the correct answers. And as far as I understood these concepts, it's the main difference between these 2 types of machine learning.
Who has anything to add? Valeria, both? How did you understand the difference between these 2 types? Both, Valeria? Unmute yourself, please.
Yes. I can't add.
I wonder why. Be more active. It's what we were discussing. It's what you were engaged in. Yes, Maxim Vasilchuk. The difference between these 2 types of AI is you missed. I see. Valentina, what? You don't know. I see, unfortunately. Valia skipped a key word, one word to add, and the answer would be perfect. Maxim Fedorenko, according to the quiz.
I don't remember, but maybe with results.
With results. Arsen?
May I try?
Who?
Evgeny Vasilyev.
Evgeny, yes, closer to the mic, Zhenya.
Supervisor, when we use supervisor, it's like a teacher, I think.
Yes, you are right. And in reinforcement learning, is there a teacher as well?
No. They teach by itself.
It
in
teaches
reinforcement method.
by itself. There is also a teacher. Teaching is also implied. It's what they have in common, but there is one great difference. Who heard, who remembers that difference? Alexander Kaplenka, sorry.
I don't know.
Oля Bukhantsova. No ideas, everyone skipped. Adalbert, Ira Patienko. Mike, perhaps you will say, with reinforcement, Mike, I know that you remember, you have to, Mike.
I think everything was stated.
You skipped the word, such idea as rewarding. Reward, Mike, did you mention it? You said, oh, Vala, sorry, I skipped it.
I'm sorry, but I told that them. Yeah, I told that. So if we maximize the reward, it's like obvious that we give some reward.
Okay, perhaps I understood you differently. Thank you, Vala. Yes. So what kind of rewarding is it? That one which Vala mentioned. How can we reward a system? Giving a candy or what? Uliana, what kind of reward is meant? Do you understand what we are talking about?
Yes, I understand, but I don't know answer.
I answer.
Arsen wants welcome, yeah?
Yes, we give sponge to this intelligence.
A bunch?
A points like
Points.
yes, some value, and artificial intelligence trying to maximize it.
According on our evaluation, yes?
Yes.
So, Arsen mentioned points, and Arsen mentioned some evaluation, or how else can we call it?
Marks.
What do we give? Arsen, thank you. Who can give us other words? This rewarding is in terms of what? Nikita?
I don't know, maybe it's marks or some amount of points or another things.
We give our feedback. We give our feedback, and our feedback, yeah, from it itself learns. It analyzes the mistakes made and avoids them in the future. Our feedback is the thing that matters in reinforcement learning. In all other types, there is no such an option. So it's clear. Good, great. We mentioned some projects within AI, some current projects. And the first, which not all of you knew, is deep text, Facebook deep text technology. Facebook deep text technology. Olga Babko, what can you say about deep text? Characterize it, please.
About only Facebook?
About deep text. Okay, you may not speak only about Facebook. Deep text technology. What is this?
Previous lesson we talked about information which program catch and give us only information about what we read and about what we can talk. I don't know what how it works. But I think that program catch some main sentences in the text and post which we see. And give us maybe the same.
Adalbert, what would you add to Ola's explanation, to Ola's vision of the program essence? Adalbert.
I can add that
Can I
this
see
technology.
you? Can I see you? Can we all see your face?
Yeah. So I think this technology helps to search some patterns in the text and then do predictions for customers.
And last time, Maxim Fedorenko, we mentioned one word. The main aim, the main function of the program is to provide us with the result according to what? According to what? To the history of our search, yeah? It filters our history search and gives us only the up to date, the relevant information. Yeah, history of our searches. We also mentioned it last time, filtering operations and more. It's about deep text. It's about deep text. Good, great. Self-driving cars. Yes, self-driving transport. We also mentioned last time. Diana Zlashchasteva. Describe, please, the technology in a few sentences. Diana, and we want to see you, please. I see. If a student keeps silence, I just put a minus, you know, it's just, I can neither see you nor hear. Ira Patienko. Self-driving vehicles.
Self-driving vehicles.
VE, not vehi, Ira, please. Vehicles.
Actually, it's a technology which provides the ability to to sit in the, for example, in the car, and the car will drive itself without your participating in it. But actually now, of course, you should sit in this car and control it if some situations maybe can go wrong or something like this.
Can go wrong or something like this. Okay, thank you. What do you remember from the history of AI? Who is the founder? Who is considered to be the father? When it all started? Why? What triggered its development? Nikita Derябin? History of AI.
I don't remember about history of
Nothing.
AI. I don't remember.
We mentioned it. Bye-bye. Artyom Davityan.
Yes.
History. A few facts from its history.
I remember that we talked about. I remember we talked about something about the Turing machines and something like that. But as if I remember correctly, the father of AI, the creator of the term and else is John McCarthy or something like that. It's a computer scientist that created this term.
Okay, terms creator, yes, John McCarthy, but the father, the person who started it all, is considered to be
Turing.
Turing, yeah, Alan Turing. When did it all happen, Valeria? Both? When did it all start?
When?
When, yes, when?
And Second War.
Yes, after the World War II, yeah, in
That is machine for Enigma. Yes.
Turing's machine for Enigma, or what? What did you say?
One moment.
You are searching for anything. We don't have much time for that.
For description code, Enigma.
For decrypting, yeah, for decrypting the Enigma's code. Valeria was searching for the word розшифровка. So, шифруємо, yeah, розшифровуємо. Give us words, please, other words. Оля Буханцова. Розшифрувати.
Maybe correct the code.
Correct the code. Correct the
crack. Crack, like...
Crack. Це взламати, а розшифрувати. Зашифрувати, розшифрувати.
Encode, maybe.
Decode and encode.
Decode, we encode and decode. Other words.
Decipher.
Yes, in cipher, decipher. Не cipher, cipher. In cipher, decipher. So, encoding information, decoding it. Inciphering it, deciphering it. Right. Cracking the code, breaking the code. Yeah, the Enigma is something different. Okay, that will do. So that's it on the first topic we did last time. I want you to learn more, not just to be present, but to participate actively. Do you hear me? Do you?
Yes,
Something happened on my screen. So our topic 2, the next topic we are going to deal with is robotics. Does everyone see my screen? Do you see it? Robotics.
Yes.
Human action replication through machines. Replication. So replication means what? Replication, if we replicate, what do we do?
Made it to look like us.
Louder?
We made them to look like we are.
We make them to look like we are. Okay, who can explain in other words? If we replicate something, our action.
To make copy of, to my mind, it's to make copy of somebody's behavior and somebody's behavior.
Okay, so emotions or to copy something, to mimic something, to simulate, not stimulate, simulate. Simulation is the word we also need to remember. Good, great. So first of all, we are going to watch the video on the key steps in robotics history. A very quick one, just the main streams in the robotics history. Before watching, read the list of questions and get ready to answer them. Here is the list of questions. Nikita, read them all, please, just for questions.
How was the term robotics originate? Which mechanism was the first true robot? Which machine is the most advanced humanoid robot nowadays? Which areas of robots application have been mentioned in the video?
Which areas of robots application have been mentioned in the video? So look through the questions one more time. Look through them, please. And in a second, we will start watching the video. Ready? Tell me, please. I will ask you to tell and to learn whether you can hear everything, whether everyone yeah, sees everything, because I'm not sure whether the video will be available. So is it okay? Do you hear? Can you see everything?
Yes, everything's all right.
Oh, thank you. Oh, sorry. Here it is.
Sorry, but we can't hear it. We can see, but can't hear.
You can't hear. Previously, everything was great. Yeah, now not. But not the sound. I need to turn on the sound in Zoom. I need to choose the advanced, yeah, the advanced, or perhaps here it is, share. So here it is, share, and do you see anything? Can you hear? No, not now. Now.
Tech play by Carol Chopek called Rossum's Universal Robot. While French inventor Jacques de
From the very
Vaucanson,
beginning.
But we can
the
see.
term robot comes from the word
Yes, we
robot,
can see.
meaning serf labor,
We
and was
can
first popularized in the 1920 Czech play by
I'm
Carol
sorry,
we
Chopek
can't
called Rossum's
You can't see the video.
Yeah. Yes.
Universal Robot.
You turn off the demonstration.
While French inventor Jacques
What did I do?
I think you turn off the demonstration of the screen.
I wonder what happened. Okay, let's start from the very beginning. So stop sharing and then start sharing one more time. So share, and now do you see my screen? No?
No.
Now you're done. Share screen, basic. Let it be basic. Now you see, yes?
Yes.
Yes, we see.
So what's going on now?
Yes.
No, we can see.
We see, but don't.
We see,
Oh no,
but
no sound, no sound. We can
no
see,
sound.
but don't see.
Maybe you can try share all your screen, not just like presentation.
Maybe you just
No
can
sound.
share a link to this video and we can watch it by ourselves.
You are saying something I can't understand. So look, I will do the following. I will send this video in our Telegram group and watch it on your own, please. Watch it twice and then get ready to answer the questions. Agreed? We will do like that because I can't understand whether you hear or you can't or you don't. So here is the video. Please open it on your own. Please and watch. So is it available? Can you hear everything now? Can you open it?
Yes.
Yes,
You
it's
can.
available.
Okay, watch it. Watch it twice, please. Watch it twice.
The term robot comes from the word robota, meaning serf labor, and was first popularized in the 1920 Czech play by Karel Čapek called Rossum's Universal Robot. While French inventor Jacques de Vaucanson is credited with creating the world's first true robot in 1738, early pioneers also include Japanese craftsman Tanaka and inventor Nikola Tesla. Elmer and Elsie, the first electronic autonomous robots, were created by William Walter in Bristol, England in 1948 and 1949. The first truly modern, digitally operated, programmable, and teachable robot, however, was George Devall's Unimate in 1954. We can trace advances in robotics technology from the Unimate to Wabot 1, the first anthropomorphic robot, to Honda's Asimo, now considered to be the most advanced humanoid robot in the world. While today's robotics help us build automobiles, act as practice patients for dentists, and even help surgeons perform operations, future advances will likely continue to make our lives even easier. The term robot comes from the word robota, meaning serf labor, and was first popularized in the 1920 Czech play by Karel Čapek called Rossum's Universal Robot. While French inventor Jacques de Vaucanson is credited with creating the world's first true robot in 1738, early pioneers also include Japanese craftsman Tanaka and inventor Nikola Tesla. Elmer and Elsie, the first electronic autonomous robots, were created by William Walter in Bristol, England in 1948 and 1949. The first truly modern, digitally operated, programmable, and teachable robot, however, was George Devall's Unimate in 1954. We can trace advances in robotics technology from the Unimate to Wabot 1, the first anthropomorphic robot, to Honda's Asimo, now considered to be the most advanced humanoid robot in the world. While today's robotics help us build automobiles, act as practice patients for dentists, and even help surgeons perform operations, future advances will likely continue to make our lives even easier. The term robot comes from the word robota, meaning serf labor, and was first popularized in the 1920 Czech play by Karel Čapek
Okay,
called
please make a pause and help me. Nikoparets, Julia, I can't find you. What group are you from? Julia, Nikoparets. So stop watching the video, please. Nikoparets, Julia.
OM4.
OM4?
Nikiparet. OM4.
I don't see you with, yeah, I remember. You with the messaging. Uliana Kostyuchenko, give me your group, please.
OM4, like Yulia.
The same, I see, good. Then Maxim Vasilchuk.
ТТП.
ТТП, Vasilchuk, Maxim. Valeria Boft.
Delphi.
Maxim Los. Maxim.
Satur 4.
Patienko, Ира.
ТТП.
ТТП. Patienko. Ira, you were not with us last time. Those who were absent last time, don't forget, to complete the first topic. Then Patienko, Adalbert Makarovich. And Zloschastьева. Zloschastьева.
MSS.
Diana, I see. Good, great. So let's return to the questions. You have watched the video and now the questions to answer. The questions to answer. Here they are. Why can't I share it? What's going on? Something happened. Now I can't open
The term
it at
robot
all.
comes from the word robota, meaning serf labor, and was first.
I see. Sorry. Something happened. Now, yes. So you remember that the questions here are the questions for you to answer according to what you watched. The first, how was the term robotics originated? Diana Zloschastьева, tell us please, how was it originated according to the video? Diana.
I don't know.
Did you watch the video?
Yes.
I wonder, I don't know. Yulia Nikiparets.
It comes from the word rabbi, personal slave.
Personal slave. So it comes from which word did you give?
It was like rabbi or something like this.
Rabbi. Who heard the word?
Robota.
Robota. Just robota. It's a Latin word. Meaning what? Personal slave, or it was given
Serf slave.
Serf work. It was given. Serf work.
Yes.
So is it like when we work on our own, when we are creative and active, or it's something absolutely different? Do we work on our own if we mean like self-working?
Can you repeat the question?
Do we work on our own if we mean self-working?
No.
No, we don't. So here is about replication, Question 2, which mechanism was the first true robot? Denis Pivin. Denis, answer please question 2. Louder, Denis. I can't hear you at all. By Nikola Tesla. Created by Nikola Tesla. Was it the very first robot? Was it? One of the first. But which mechanism was the first true robot? Sasha Kaplenko, what did you learn?
The term robot comes from the word
Don't
robota,
forget to
meaning
restart,
serf
less than
labor,
1
and was
minute
first
left.
popularized in the 1920
Sasha
Czech play by
Kaplenko, do you
Karel
hear me?
Čapek called Rossum's Universal
Yes, I can
Robot.
hear you.
Answer
Yes.
question 2,
The
please.
first robot was Rossum's universal robot. No, it is
So Sasha is sure that the first one was created by Russell. Who heard something different? Andrei Stetsuk.
Russell's Universal Robot, it's a book at first, as I heard right, if I heard rightly. And the first robot was invented in 18th century, in 1748 or something like this. And if I see rightly, it was like a duck or something like this.
Yeah, it looked like a duck. So a duck-like robot created where? In what country?
And
In French.
Who remembers the country? Who remembers the country?
That is French mechanic.
Yeah, a French mechanic. Yeah, it was a French mechanic. In the 18th century, a duck-like robot is considered to be a true, the first true robotic mechanism. Quite right, the first true robotic mechanism. So you can see my screen. Let's go to question 3. Question 3, Valeria Boft, answer it, please.
Which machine is the most advanced humanoid robot nowadays?
According to what you saw. Name it, please, and the company, the producer. Lera, no ideas or what?
Don't remember.
You don't remember. Lois, Maxim.
Yeah. What's the question was? I'm sorry.
Question 3.
Oh, it was made by Honda, I suppose. Yeah. I don't know. I don't remember the exact name.
Who remembers?
Something like Asimo.
Asimo, yes.
Yes.
Is Honda a producer?
Yes.
Yes. So Honda's Asimo is considered to be the most advanced humanoid robot. And question 4, the last one, the areas of application to be mentioned. Ira Patienko, the areas. Give us a list of the areas from the video.
Robotics use in the areas like automobile, in medicine. These robots help people to make different operations, and something was.
So 2 main areas, yes, Ira is absolutely right. Automobile industry, then medicine, yeah. Particularly is in surgery. Perhaps one more area.
And like the robots which like actually replicate humans' behavior and looks like real humans. I think it's like in this niche. I forgot how it calls exactly in video.
Mike Lahachov, do you remember the last area mentioned in the video? Is there Mike? Arsen remembers. Welcome, you are.
There were mentioned robots for surgery operations.
Shorter searching operations.
Yes.
Okay. Doing what? Performing what tasks?
Medical surgeon operations, difficult surgeon operations.
We mentioned it. Ira mentioned medicine was given and human movements replication as well. Done. Great. Let's continue. Do you see my screen? The question, yeah? Do you?
Yes.
So we are going,
Yes.
according to the video, we heard that Honda's Asimo is considered the most advanced humanoid robot. But let's compare a bit more. I want you to see to look at the images and try to compare and finding out an answer. What robot is the most advanced? So you will be given a pair of images to compare and to share your guesses. Which one out of two given is more advanced and why? So let's have a look at the first, comparison. Alexander Kaplenka. First of all, which robots do you see? How can you describe them and try to compare, saying which one is more developed? Kaplenka.
I see the robot Asimo. It's a robot, seems like a human. He can run, walk, maybe something carried.
Not carried, but he can. Yeah, he can carry items.
Yes, carry items. And
I'm sorry, Alexander, why is it so noisy? Can you ask those who are
Andruha.
with you?
Andrei.
Turn off the sound. Yeah, let them turn off the sound. Keep speaking.
Okay. And the other robot is I don't know what it can do, but I think Asimo is better, not better, more.
More what?
Can do,
more? Help us. Give us the word. More advanced, more
yes.
developed. Yeah, I see. The second robot, Alexander hesitates, but Maxim Gnatishka does not. Which robot do you see on picture 2, on image 2? Maxim, how would you describe it? Or perhaps you know how
Okay, we see the robot that do not look like human, and I guess this robot is made to do some surgery operations, maybe, because he has the instrument that seems to be for that. For surgery operation.
This pointed edge, you think are enabled to operate. I wonder. Let's ask Patienka, Ira, what do you think? Is it applicable in surgery, the second robot?
Actually, for me, it's also hard to understand, like, for what was created this robot. But like, as for me, it looks like similar to the robot which can how it's said, like to put some heavy things and like to put it somewhere on the other place. I think, I don't know, maybe it's also for medical it using medicine, but I actually don't know.
I see. Who disagrees with Ira? Yes. Who wants?
This robot can operate in very small spaces, so it can be used in some operations that can save, in medical operations, and also it can be in searching operations when building is destroyed and people are under stones and the walls, and this robot can successfully search for people.
So one more option is added. Thank you, Zhenya. In Jan Hazardier's environments, yeah, in case of some crashes, some explosions and more, where it's dangerous for, yeah, for people, for rescue men to be, even for rescue men. So it can be applicable for searching victims, for searching people who are under the broken buildings. Good, great. Tell me please, what does it resemble? Robot 2, the second robot. What does it resemble? Perhaps an animal?
It's like snake or worm.
It's a snake-like robot, yes. So who believes that Asimo, yeah, Honda's Asimo is much more advanced? Raise your hands. I want to see. Raise your hands. Who believes? Only 5 students. Only 5 students. 6. So the majority disagrees. The majority disagrees. Okay, who disagrees? For whom a snake-like robot is much more advanced? For whom? For whom? For Yulia. Why, Yulia? Why do you believe so? Why?
Because to my mind, it's much more difficult to work with human and robot task is to keep people healthy, and it's much more difficult than just duplicate people's behavior.
Who supports Yulia's decision? Who supports? I missed. Who also raised the hand? Okay, Adalbert, what would you say as for a snake-like robot advancement?
I think that snake-like robot has more specific and more interesting tasks than just modeling a human behavior.
Just modeling a human behavior. Okay, let it be. It was your choice. Let's continue. Do you see my screen?
Yes.
Do you see the second? Yeah, the second pair of images. Do you?
Yes.
Yes, you do. Great. Maxim, Natishka. So what do you see and which one, in your opinion, is more developed?
Okay, we see 2 pictures, and at the first picture we see the small robot that, in my opinion, can fly, because he had Krila. I forgot the word.
Who remembers Krila? It has wings. Yeah, thank you. Wings.
He has wings in his construction and maybe other electronic on his body, and he can go in small holes to find out the information.
Find out information. There is a coin. Yeah, there is a coin.
A coin,
it
yes.
means that
this robot is small. The coin is
tiny,
to compare his sizes.
Okay. Okay. Thank you. Thank you. Thank you. And picture 2. And on picture 2, we can see. Whom have not I asked yet? Uliana, we can see.
We can see a big robot who can copy humans' behavior, I think, and people who create it, they want to improve outside. They want to create a robot who can look like human, and it's important to create a robot who very similar
to us. I see. Okay, Vala, what's your decision? What's your idea? Which robot is much more advanced? out of this?
Unfortunately, I don't know because they serve two different purposes. So it's hard to
Your
compare
guesses.
them.
Your guesses. No one knows for sure. Just we are guessing.
I'd say that
discussing.
the first one probably. It has
That tiny one, yeah?
Yeah, it has
That tiny one. Why? Why?
It has like smaller details, so it's like harder to work with this type of robot, and I think that he has like more purposes. So probably this one is more complex.
Wider purposes, you mean this, yeah? Wider, richer, a richer range of purposes to gain. I wonder, interesting, who supports Vala's idea, Vala's decision that the first tiny robot, yeah, an insect-like robot, is more advanced? Raise your hands one more time. Arsen, I see. Who else? Who else? Alexander, Nikita. Ola Bukhantsova disagrees. Yeah, for her, they said, Ola also supports. For whom the second robot, a human-like robot, is more advanced? For whom? For Yulia, for Ira. Okay, for Diana, I see. Good. So let's check. So you see my screen, right? Don't you? And now we've got the text. You are supposed to read the text and find out what is assumed about robotic sophistication level. So sophistication is advancement. Is advancement. Is the level, to what extent something is developed. So compare the given information with your previous suggestions. Firstly, read the text. Who wants to read? Or you will do it individually?
It would be better to do it individually.
Okay, read it on your own, please. On your own pace. Okay, done. And now, please, what can you assume? Were your all suggestions true? Maxim Fedorenko.
According to the text, we can find that the snake robot, yes, that snake robot is more advanced than Asimov's robot. But
thank you, because Maxim lost, because. Thank you, Maxim. Because
of its size.
Because of its size.
Yeah.
Because
But
of the
I'm not sure if we can say that after reading the text that it's more sophisticated, because in the text, in the end of the text, it was mentioned that the sophistication level should be measured by the task they should perform. As we see, Snake robot has kind of interesting form, as well as this like insect robot. But for example, Asimo, for his tasks doesn't need for its tasks doesn't need such a form or to be such a small robot. So sophistication is like should be measured by its tasks. So I can't say that. So I can't say that like robots is better.
But according to the text, Diana, were all their suggestions you made correct? I mean, in comparison, the level of sophistication, Diana. Диана Злосчастьева. What group is she from? Who knows? Злосчастьева Diana. Something is wrong with her connection with the sound or I don't know with what. Оля Буханцова. She is from your group. Yes, Оля Буханцова.
Yes.
Yes. After our meeting, can you contact her and say that it's not, it's not participation, not to react, not to reflect on anything is just about nothing. So it's minus. Could you do me a favor, Ola?
I guess.
Thank you. So what would you personally say according to what you read?
Well, it's the text said that more advanced robots are the ones that do tasks which people can do. The robots that help people in place where they can't survive or can be harmed.
Can be harmed. I see.
Yes.
Can be harmed. Good, great, thank you, Maxim. Now let's think more. Maxim, why do you think the authors of the text have assumed that snake-like and insect-like robots are more sophisticated? Vasilchuk.
You're asking me, yeah?
Vasilchuk, Maxim.
Vasilchuk.
Can you repeat the question?
Why is it assumed that snake-like and insect-like robots are more developed? Why?
I think it's more easily to develop them, and
it's easier to develop them.
Maybe it's can be used in more ways than humanoids because we don't need to accelerate their position and
and you did not hear my question. Why are they considered to be more developed? Why, Nikita Dirabin? Why?
I think because it's very tiny and it is very hard to implement a big functionality in a small thing.
Yes, it's because of this tiny size, yeah, thus extremely small particle constituents. They are much more difficult to boost the functionality. Good, great. So we've done it. Let's continue. We are going to watch the next video revealing the robot's building process. According to what you will watch, your task is to mark the following statement as true or false. in our further coming discussion, we would correct the false statements. So firstly, read the statements from 1 to 10, then watch the video and mark each as true or false. You need to send me your answers in in forward messages, in direct messages, not for everyone to see. So now statements. Now statements. Artyom, read them, please, for everyone to hear. Artyom.
Okay. First one, robots can hardly be applied into every single today's industry. Second, engineering innovations are pushed by data availability and prices reduction. Third, robots are as easy to be understood as the other machinery.
Thank you, thank you, thank you. Then Lera Kostelnikova. Number 4.
Yes, 5 key human features have been simulated in robotics. 5, a robot's controller receives commands and instructions to follow. 6, water, air, and electric current enable robotic movement. 7, the 60s rigid robotic true to life implementation. True to life implementation.
The 60s the year period. Thank you, Lera. Yulia Nikiparets. 8. Yulia.
Yes. Through the air operations, Snakey was capable of logical deduction and decision making.
Shaky is the name of a robot. VR operations, Yulia, what are they? VR. What does that VR stand for? What does it stand for?
Oh, yes. I don't know.
Who knows?
Virtual reality.
Virtual reality, surely. It's about virtual reality. Not augmented, but virtual. Yulia, keep reading. 2 more.
Robotic motion modeling is a mainstream of Boston Dynamics.
And the last one?
Oh, I don't see. A second.
Who sees? Who can see? Who can read?
I see.
Robotic motion modeling is
read, please. Who can see?
I see.
The advances within robotics have given at home developed mechanisms ago.
Yeah, the advances within robotics have given at home developed mechanisms ago. They have given a go to at home developed mechanisms. We will do the following. In our group in Telegram, I will send you this list of questions. This list of questions. Here they are for everyone to see. So, is this list available? Do you see it?
Yes, we see.
And now the video, And how much time left? How much time left? Not much?
Maybe 10-15 minutes.
So, you need to watch the video twice and send me your answers in Telegram, not in Zoom chat. I'm afraid that I won't have enough time to check. Please send everything in Telegram, in direct messages. Agreed? In Telegram, not in Zoom chat. You need to send me a list of your answers, like 1 true, just T. Second, F, false, 3 T, 4 F. Got it? No correction, nothing, just your answers. Is it clear?
Yes, it's clear.
Yes, it's clear. I will give you let it be 10 minutes to complete the task. There is 10 minutes left. So till the end of our meeting, please, all the answers should be sent. Agreed?
Yes.
Good. So, yeah. The video is already available. Can you open it, please? Say it. Or not? Can you start a video? Is it okay?
Not yet.
Not yet. Yeah. It's being downloaded. No, it's not available yet. So nearly 80% is done, is completed. So now I guess everything is all right. You can open it. Can't you?
Yes, we can.
Great. Start watching it. Watch it twice and mark the statements as true or false. Waiting for your messages, yeah, with answers.
Robots have jumped from the screen and science fiction pages into our reality, disrupting almost every modern industry. Agriculture, space, travel, medicine, and manufacturing are just a couple of places robots have begun to appear. You could argue that they have already started to take over our world. Just in the past few decades, robots have reached new heights. The continual and rapid progress of artificial intelligence, paired with readily available large data sets, lower prices for sensors and electronics, and a steady demand for efficiency, has created the perfect storm for engineered innovation. Yet you should not be intimidated by robots. Though robots are certainly complicated pieces of machinery, they are also delightfully simple to understand. In a lot of cases, robots are based on us humans. You can even build your own simple robot at home. But before you can go off and make your own, you should understand a robot's workings first. Defining a robot can be tricky, as it tends to be used as a blanket term to describe any machine that can perform work or other actions normally performed by humans, either automatically or by remote control. On the most basic level, there are 5 major human organ systems that have a corollary in robotics. A skeletal structure, a muscle system to move the skeleton, a sensory system that receives information about the body and the surrounding environment, a power source to activate the muscles and sensors, and finally, a brain that processes sensory information and tells the muscles what to do. Many types of robots also include these systems. First, you have the controller of the robot, which could also be called the brain of the robot. A computer program usually runs this, and it gives the robot detailed commands to follow. Secondly, you have mechanical parts. These can include the motors, pistons, grippers, wheels, and gears, and help the robot move, grab, turn, and lift. They are usually powered by air, water, or electricity. Robots also have sensors that help them determine sizes, shapes, space between objects, and direction. And finally, robots have a power source. All of these components work together to control how a robot operates. Throughout the history of robotics, each of these components has improved vastly. Robots have been a long-standing trope in science fiction. However, by the 1960s, they were actually becoming a reality. The first real effort to build an autonomous machine that could move, reason, and act in its environment was the robot Shaky. Brought to life in 1966, Shaky is considered to be the world's first robot to embody artificial intelligence. Shaky could perceive its surroundings, logically deduce implicit facts from explicit ones, make a plan to achieve a goal, monitor the execution of a plan in the real world, and even correct its own errors. Shaky marked a new era in the age of robotics and computer science. Some of the algorithms used in robots and AI today have directly descended from Shaky. The area of robotics has evolved at breakneck speeds. Companies like Boston Dynamics are leading the charge, creating robots that can almost move as well as you. Honda's Asimo can learn independently, walk on 2 legs, and climb stairs. Toyota's THR3 humanoid robot has been designed to fill a wide range of roles, like cleaning, construction, caregiving, or simple companionship. Thanks to these rapid developments in robotics, building your own robot at home has never been easier. You don't need that much. There are extensive communities out there dedicated to those of you interested in creating your own intelligent machines. When creating your own robot, you first have to decide how it will be used. Is it simply for fun and amusement? Are you trying to enter the world of robot engineering? Or maybe you just want a robot for your desktop. Robots have jumped from the screen and science fiction pages into our reality, disrupting almost every modern industry. Agriculture, space, travel, medicine, and manufacturing are just a couple of places robots have begun to appear. You could argue that they have already started to take over our world. Just in the past few decades, robots have reached new heights. The continual and rapid progress of artificial intelligence, paired with readily available large data sets, lower prices for sensors and electronics, and a steady demand for efficiency, has created the perfect storm for engineered innovation. Yet you should not be intimidated by robots. Though robots are certainly complicated pieces of machinery, they are also delightfully simple to understand. In a lot of cases, robots are based on us humans. You can even build your own simple robot. Robots, paired with readily available large data sets, lower prices for sensors and electronics, and a steady demand for efficiency, has created the perfect storm for engineered innovation. Yet you should not be intimidated by robots. Though robots are certainly complicated pieces of machinery, they are also delightfully simple to understand. In a lot of cases, robots are based on us humans. You can even build your own simple robot at home. But before you can go off and make your own, you should understand a robot's workings first. Defining a robot can be tricky, as it tends to be used as a blanket term to describe any machine that can perform work or other actions normally performed by humans, either automatically or by remote control. On the most basic level, there are 5 major human organ systems that have a corollary in robotics: a skeletal structure, a muscle system to move the skeleton, a sensory system that receives information about the body and the surrounding environment, a power source to activate the muscles and sensors, and finally, a brain that processes sensory information and tells the muscles what to do. Many types of robots also include these systems. First, you have the controller of the robot, which could also be called the brain of the robot. A computer program usually runs this, and it gives the robot detailed commands to follow. Secondly, you have mechanical parts. These can include the motors, pistons, grippers, wheels, and gears, and help the robot move, grab, turn, and lift. They are usually powered by air, water, or electricity. Robots also have sensors that help them determine sizes, shapes, space between objects, and direction. And finally, robots have a power source. All of these components work together to control how a robot operates. Throughout the history of robotics, each of these components has improved vastly. Robots have been a long-standing trope in science fiction. However, by the 1960s, they were actually becoming a reality. The first real effort to build an autonomous machine function. And finally, robots have a power source. All of these components work together to control how a robot operates. Throughout the history of robotics, each of these components has improved vastly. Robots have been a long-standing trope in science fiction. However, by the 1960s, they were actually becoming a reality. The first real effort to build an autonomous machine that could move, reason, and act in its environment was the robot Shaky. Brought to life in 1966, Shaky is considered to be the world's first robot to embody artificial intelligence. Shaky could perceive its surroundings, logically deduce implicit facts from explicit ones, make a plan to achieve a goal, monitor the execution of a plan in the real world, and even correct its own errors. Shaky marked a new era in the age of robotics and computer science. Some of the algorithms used in robots and AI today have directly descended from Shaky. The area of robotics has evolved at breakneck speeds. Companies like Boston Dynamics are leading the charge, creating robots that can almost move as well as you. Honda's Asimo can learn independently, walk on 2 legs, and climb stairs. Toyota's THR3 humanoid robot has been designed to fill a wide range of roles, like cleaning, construction, caregiving, or simple companionship. Thanks to these rapid developments in robotics, building your own robot at home has never been easier. You don't need that much. There are extensive communities out there dedicated to those of you interested in creating your own intelligent machines. When creating your own robot, you first have to decide how it will be used. Is it simply for fun and amusement? Are you trying to enter the world of robot engineering? Or maybe you just want a robot for your desktop.